36. 36 times 2 is 72. That's your diameter that you want to plug in there. So just be careful with that. So I'll let you guys do that one. Let's move on to number 11. These ones get a little bit tougher, so I want to make sure I review 11, 12, and 13 here. So essentially, it's the same thing. It says, how far will the tire travel with a 270-degree rotation? So 270 degrees is 3/4 of the tire, right? So if I go 1/4, that is 90 degrees, right? If I go another 1/4, which is 1/2, that's another 90 degrees. If I go another 1/4, that's another 90 degrees. So that's 3/4 of the circle, right? And 90 times 3 is 270 degrees. So essentially what they're asking us is, what is the length of that tire? How far did you go, right? If I went 3/4 of the tire length. So that's circumference. So I'm going to do pi times diameter, which will give us the full length of the entire tire. But I don't want the full length. I just want 3/4 of it, which is why I'm multiplying it by 270 degrees out of 360 total degrees, right? 270 out of 360 is 3/4. So I just want 3/4 of that. All right, so the diameter, like we said, was 72. So I'm going to say 72 pi times 270 divided by 360. Punch that in, 72 times pi times 270, then divided by 360. And I got 169.6. Hopefully you're getting the same thing. 169.6 centimeters, approximately, after we round it. Hopefully that makes sense. If you guys, here, I'll slow down here for just like 30 seconds, maybe 20 seconds or so. That way you guys have time to catch up, ask a question. You guys, again, put it in chat. You can unmute your mic and ask. You can send a message on Remind, whatever you prefer.
I wanted to ask, since I was like a couple minutes late, we're finding the center length, right?
We're finding, so arc length is essentially the length around the circle, right? That's what the circumference is. That's the length around the entire circle, right?
Mm-hmm.
So arc length is just certain parts of the circle, right? So if I go up to like this one that I did right here, right? So we found the arc length of AC. So that's not the entire circle's length. It's just a portion of the circumference. Does that make sense?
Yeah, okay. So instead of like the sector, like r squared, it's just diameter?
Right. So because on Monday when we did that, it was sector area. It was the same concept, but area is pi r squared, right?
Yeah.
So today it's not area, it's length of the circle, which is not pi r squared. It's pi times diameter now.
Okay.
But it's the same concept.
Okay, that's all I wanted to know.
Okay, good question. Thanks.
For number 11, how do we know to use oh my god, what's it called? Arc length instead of like sector area. Like how do we know like
great
what
question.
We're supposed to use?
Really good question. So the key is right here in the beginning where it says, how far will the tire travel? So it's not asking for area, it's asking how far, which is length, that's distance, right? Does that make sense?
No, not really.
Okay, so if I said how far will the tire, so if I have like a wheel right here, excuse my drawing, here's a wheel, right? So if the wheel is traveling, how far, eventually if I rolled out like the circle, it's going to be a straight line, right? Imagine if I cut a circle and laid it out flat, it's going to be a straight line, right?
Mm-hmm.
So how far will it travel means 270-degree rotation, which is 3/4 of the circle, right? Which is 270 out of 360. That's why we're multiplying by that. So
but like my question, sorry, continue.
So to answer your question, like, how do you know which one? When it's asking how far, just think of length. That's arc length. If I say, how far is something? Well, you're going to tell me like something in centimeters or inches or feet, right? That's not area. Area is the space inside of an object.
Okay, and then say for sector area, how do we know to use sector area?
Okay, so that would be like they're gonna ask you like, that one's a little bit easier because like when they're gonna ask you like how, like what is the space inside of something, the question might ask, or it's probably just gonna ask you directly like what is the area, right?
All right. Okay.
So that's how you can tell at the beginning of the question. It'll say how far. Well, how far is the length of something? So that's gonna be arc length.
All right. Okay. Thank you.
Yeah, I know it can be a little confusing. Good question. All right, let's keep going. So the next one, it's going to be the same type of thing. So how far will it travel? That is arc length. All right, so that means I need to do circumference, which is pi times diameter. That gives me, again, the whole length of the entire circle. But I only want a 180-degree rotation, which is half of the circle, right? 180 is half of a circle. So I'm going to multiply this by 180 over 360, which you'll notice is 1/2, right? You could just multiply by 1/2. It's the same exact thing. All right, so you're going to just plug it in, same exact thing. Grab your calculator, and we're plugging in 72 because it's the same exact tire. So it's 72 pi times 180 out of 360. And that's going to give us your the length that the tire will travel if it went half of the tire length, 180 out of 360. So 72 times pi times 180. And then, whoops, 72 times pi equals, and then it's divided by 2. Okay, I got 113.1 on that one.
Yeah.
There you go. 113.1 centimeters. Okay, 13 is repetitive, so I'll let you guys try that one. It's the same exact thing, pi times diameter, but this time you're going to multiply it by 60 out of 360. And again, it's saying how far will the tire travel, right? So that's not area, that's a length, that's arc length. All right. Let's move on. 14, these can be kind of tough, so I wanted to make sure and review these ones right here with you guys. So 14, it says, what's the circumference of the clock? So that's not area, that's circumference, right? It directly says circumference, so that's how I know. Well, circumference, the clock is circular, so the circumference of a circle is going to be pi times diameter. And it's not asking for like a portion or anything like that. You know, it's not saying like just a certain portion. It just says what's the full circumference of the clock. So all I need to do is just plug in the diameter and multiply by pi. So it says the minute hand of this clock is 4 inches long. Well, you'll notice that the minute hand is actually the radius of the circle. So if I multiply that by 2, 4 times 2 is going to give me 8. So 8 is my diameter. So we'll plug that in for there. So the circumference is going to be 8 pi. And then we can just approximate it. So 8 times pi is 25.1. So 25.1 inches about is the length around that whole circle, about 25.1 inches. Okay, 15 and 16, it gets a little bit more complicated, but not too bad. You just got to understand what you're reading here. So it says, how far will the end of the minute hand travel in 20 minutes? Okay, so you guys, how many minutes is a full circle?
What?
How many minutes is a full circle, like 1 hour?
60 minutes?
60 minutes, exactly. So if it's traveling 20 minutes, I'm going to multiply it by 20 over 60, just a portion, right? So the circumference we already know is 8 pi from the previous problem, right? We already know that.
Mm-hmm.
But we only want to know what it's traveling in 20 minutes. Well, 20 minutes, so I'm going to multiply by 20 out of 60. Why 20 out of 60? Well, because I know 60 minutes is a full circle, right? That's the full circumference, right? So I'm just going to take 8 pi and I'm going to multiply it by 20 over 60. That's all. Which is 1/3. If you reduce that, that's 1/3. 20, 40, 60, right? That's 1/3. So times 20 and then divided by 60. If I take 8 pi, multiply it by 20, and then divide it by 60, I'm going to get about 8.4.
Yeah.
So approximately 8.4 inches. 16 is the same kind of deal. We already know that the full circumference of the circle is 8 pi from the previous problems. And then all I'm going to do, it says, how far will the end of the Minahan travel in 37 minutes? Okay, well, 37 minutes, I'm just going to multiply this by 37 out of 60 because that's the portion of the clock that it's traveling, right? 37 out of the possible 60 minutes if it went a full circle. So I'm going to do 8 times pi times 37 and then divide it by 60. So 8 times pi times 37 divided by 60. That's going to give me about 15.5. Yeah, you're right, 15.5 inches. Questions on those? Chat it. Ask, use your microphone, send me a remind message, whatever you want. Okay, if you change your mind and do, just let me know. Let's go on, let's see, the second page here. It says the speedometer above is designed using a semicircle. So that's very, very important, okay? A semicircle is half of a circle. And you can kind of see it right here, right? If I go from here to there, that's half of a circle. So that's really important with what we're going to do here. It says the length of the needle is 6. So that's basically telling us that the radius of the full circle would be 6. That's what it's saying. Now it's saying how far. So are we going to use area or is this arc length? If it's saying how far. Hopefully you guys are thinking arc length, right? So that's going to be arc length, not area. So it says how far will the end of the needle travel if your speed changes from 0 to 40. Okay, so I know, so what I'm going to do is I'm going to figure out what the circumference of half of the circle is. I want to know what we're dealing with, right? Well, the circumference of a full circle is going to be pi times diameter. So if I only want half of the circle's circumference, I'm just going to divide this by 2. And that's going to tell us the length of just half of that circle. All right. So the diameter is what? Put it in the chat. Tell me what the diameter is. Good, Damaris, good, good, Fabiola, good, 12, Nat, good, Ray, nice job, 12. All right, so diameter is 12. Elijah, good job. Yeah, so the diameter is 12. So that's what I'm plugging in for the diameter, right? So 12 times pi is 12 pi. And then remember, that's the full circle. If I went all the way around, it's 12 pi. But I don't want to go all the way around. I just want to go half of the circle. That's why we're dividing it by 2. So 12 pi divided by 2 is 6 pi. That is the circumference of half of the circle. So we know that this length is 6 pi. Okay, but we only want to know, remember, that's not our answer, because if you look, let's go back to the question. It says, how far will the end of the needle travel if your speed goes from 0 to 40? So that's only this portion right here, from 0 to 40. We just want to know that length. Okay, well, it went 40 and then 100 miles an hour is half of the circle, right? You can see 100 is half of the circle. So I'm going to take my circumference of half of the circle, which is 6 pi, and I'm going to multiply it by 40 out of 100. Why 40 out of 100? Because I only went 40 miles per hour from 0 to 40, and then 100 miles per hour is exactly 1/2 of the circle. So that's the portion that I'm going to multiply by. I'm hoping that makes sense for you. So I'm going to take 6 times pi and multiply it by 40 and then divide it by 100. So 6 times pi, multiply it by 40, divided by 100. All right, I got, that doesn't look right. I got 7.5. Let me do it again. I feel like I hit a button wrong or something. Times 40 equals divided. Yeah, that's right. 100. Yeah, 7.5 about. So this length right here is approximately 7.5 centimeters. That's a tough one. Those can be tough.